In this video we're dealing with the trapezium, so you're going to need your log tables, and you're going to need your log tables page 8. Okay, so the formula for that is log tables page 8. So it says a circle of circumference 12. Okay, so they've given circumference, no information about diameter, but we could work that out. It's inscribed in a square, so it's inside of a square, which is in turn inscribed in an outer circle. This outer circle touches the parallel sides of a trapezium as shown. Find the area of the trapezium by giving your answer in the form a square root of b all over pi. Okay, so the first thing I could do to get marks instantaneously is to write down and fill in what I do know about the area of the trapezium. So again, page 8, log tables, you're going to have that it's a plus b all over 2 multiplied by h. Now, what is the a, the b, and the h? If you look in the log tables, we have a shape that looks like this. So it comes across and down. The A is along the bottom, the B is up the top, and our H is the perpendicular height. A and B are interchangeable. The one that matters is the perpendicular height. That placement is really important. So, the only thing in that formula that we don't have in the picture is the perpendicular height. So actually, that's what the question is asking me. That's actually what I've figured out. That's what the question is. So that's the hard part. The rest is all algebra. Really coming back to the basic skills. A we have then. It's the bottom one, 5. So I can write 5 plus B, which is the top one, which is 2, all over 2. And then it's going to be multiplied by H. I do not know what that is, but I can leave it as H for the time being, or I could start calling it the diameter, or I could start calling it 2R. But what I'm going to do is I'm going to leave it as H for a while. So I can say 5 plus 2, which is 7. So I'm going to have 7 over 2H is the area for now. So I'm going to keep that and I'm going to set it aside. And that would have picked me up marks immediately. Okay. And I also, in doing that and in writing down what I do know, what I can say, I figured out I just need to find out the diameter of the circle, of the larger circle. So what we're working on now then is finding out that larger circle's diameter. So what I could find out first is the smaller circle. So if I look at the smaller circle, I know about that smaller circle that the circumference, which is equal to 2 pi r, that calculation actually gives me 12. So I could get that pink section of the line by reverse engineering the circumference formula. So let's start with that. So I'm going to write down the formula. C is equal to 2 pi r. C is 12. So 12 is equal to 2 pi r. I'm going to divide both sides by 2. I get 6 is equal to pi r. Divide that by pi, and I'm going to get 6 over pi is equal to r. And that's what the pink section of our diameter of the larger circle worked out to be. So I know that piece. The next thing then, if I go back up to our picture, the next thing that I need to figure out is I need to work out these sections here and here. I need to figure out how does the smaller circle link in with the bigger one. And what we will do is redraw it out to help us, because there's a lot going on in that picture. You don't really want to be figuring it out, looking at all of the shapes at once. So I'm going to draw my square as roughly as I can. I'm then going to draw around that R circle. So we have a circle, and I'm going to squash it a little bit to make it fit for us. Come in a bit this side, come down a bit. Now, so there's the circle on the outside, and then I know that there's a circle on the inside again. Let's give it a different colour. And this is all part of the problem solving process. You have to sketch it out. You will have to draw it out in the exam. And there is time for that in these questions. There is time built in for problem solving, sketching, working out different strategies. It's all part of the exam and it's all part of the timing. So looking at this then, what I have is the full diameter is down here, which I had previously marked in black. I'm going to mark in red for now. So there's the large diameter. What I have just figured out from the previous question is that the R, so the centre from here out to here, is our radius of the smaller circle. But what I also know is that if I was to find this across here up to there, I would be talking about the radius of the larger circle, because it's from the centre out to a point on the larger circle. Now, what is that yellow line? If I look at it, that yellow line is actually part of the diagonal of the square. Okay, so now I'm being asked to find first the diagonal of the square. That's what I want to find out. So let me draw out the square again. So again, drawing it out. Let's draw the square out. So our square is here, and I want to find that diagonal. So if I'm going to find that diagonal, I need to know the width of the square, right? So a square, all sides the same length. So if I know one of them, I know all of them. So let's find the width. But let's take a look. The width of the square, how wide that square is, how long that square is the diameter of the purple circle, the light purple circle. So let's change it to purple to match it. Hopefully you can see that. So actually this length across here is actually the radius times 2 of the smaller circle. So have a think about that. Pause if you need to, but it's twice the radius of the smaller circle. So it's going to be 2 times 6 over pi is our side length. Now, what is that? I'm going to write it underneath. It's 12 over pi. So I've got a square. The square's side length is 12 over pi. All of the sides therefore are 12 over pi. So then I need to find that yellow line. Again, that yellow line is going to be the diagonal, and it's a right angle triangle. It's part of a right angle triangle. I can figure that out then. There's 12 over pi here, and I need to find that yellow line. Let's just call it x. So, Pythagoras' theorem, the hypotenuse squared is equal to the sum of the other two sides squared. So I'm going to have 12 over pi squared plus 12 over pi squared. So I'm going to get 2 by 12 over pi squared. Is equal to x squared. And then I need to work that out. So I'm actually going to get x is equal to root 2 by 12 over pi is what our x works out to be. So that yellow part is root 2 times 12 over pi. That diagonal then, how does that come into play? So that diagonal I was looking for, I actually only wanted part of it. I actually only wanted half of it. That's the full diagonal. I only wanted from here out to here. So let's just highlight that for ourselves. I'm going to highlight it in blue. That's all I wanted. So I'm actually going to divide my answer now by 2. And I'm doing that because I wanted to find the radius of the larger circle, and that's then going to give me, if I divide it by 2, so what I'm doing is I'm finding x over 2, x over 2 is equal to root 2 over 2 by 12 pi. And I actually don't think I needed to do this. I think I'm going to end up multiplying it by 2 in a second anyway. But that then is the big R. And what I mean by big R is it's the radius of the big black circle that I drew here. It's the big radius. And why did I want that? I wanted that because I wanted the diameter of it. So there's where I need to multiply it by 2 again. So I wanted the diameter of the larger circle. That means multiply this again by 2. So I actually didn't need to do this at all. So the diameter is equal to 2 times the radius, which is going to give me root 2 times 12 over pi. That is our diameter. That's that red line there. Why did I need that? I needed that because I needed the perpendicular height of our trapezium. So this formula comes back, and I'm going to get then that I have, there's the formula for the trapezium. I actually know what the height is now. It was the diameter of the larger circle, which I now know to be root 2 by 12 all over pi. If I multiply all that out, I'm going to get 7 by 12 is going to be, let's work that out. So it's going to be 70 plus 14, so it's 84. So 84 root 2 all over 2 pi. Divide 84 by 2, you get 42 root 2 all over pi. So that's the area of our trapezium. That's a really long question, and even I had to keep reminding myself what I was doing, why I was doing it, and I don't think I would have been able to do that without drawing all those sketches out. I think that was really crucial for me, and I think I could have even helped myself even more by having subheadings. If I had subheadings of saying what I was calculating and why I was calculating it, I might have been able to get through that question a little bit faster, because I had to pause and think, wait, why was I finding the radius of this little circle? How does that connect to the larger question? I think subheadings would really help here. So again, taking it in bite-sized pieces, don't get overwhelmed by all of the different shapes. That would wreck your head to look at to begin with. So just break it down. What are they asking me? Write down the formula that you can. As soon as I wrote down the formula for the trapezium and I started filling it in, I was like, oh, they just want me to find the height. What's the height? The height is the diameter of the larger circle. Okay, how can I find that? And breaking it into smaller, more manageable questions.